All right, so on the home stretch here, we're going to do just about four more problems, all relatively um, quickly here. Here's the setup on number 8. I want to find V2, what is the voltage here? And once again, I'm going to have like my total voltage is going to be equal to the sum of the voltages in series. And so right here, I have, what is that? Well, this here would be IR. IR. We're going to add it to whatever this is that we're looking for. And of course, that equals 9. And then we have V equals, whoops, 9. And so 3 volts is going to be our V2. And moving on. So for 1011, initially this switch is open, so current is going to come through here, and then it's going to split here and here. And since they are all the same resistors, I know there's going to be an equal amount of current down this branch and this one. We want to know what the current is through A1. All right, we also know that the voltage to this whole circuit is 10 volts. All right, so if I can just find the effective resistance of the whole circuit, I'll divide that into the voltage, and that'll give me the current here, because right here is the total current. It goes through this resistor, it splits in half, it comes back together again, so it wants to know what's the current at A1, and it's going to be the total. All right, so let's get it. We have 2 and 2 in parallel, and so they're effectively going to be the resistance of 1 ohm. We have the same resistors in 2 branches, so the trick is to cut that in half, and we have 1 ohm here, and that is in series with a 2 ohm resistor. So we have an effective resistance of the circuit as 3 ohms. And so when we do V over R, we have a 10 over 3, which of course is our 3.3 amps. Number 11 asks you, what happens to the voltage across 3 when this switch is closed? So when that switch is closed, and then we just have a wire that allows the electricity to bypass this resistor. So when this circuit has this switch closed, that wire that has no resistance in it is going to have the electricity go through it 100%, and none will go through this. So essentially, by closing this switch, this resistor is out of the circuit, and then we only have these two resistors in parallel being the total resistance to the circuit. And so we go from 3 ohms as an effective resistance when this was included. And when this switch is opened, we have just an effective resistance of 1 ohm, right? So the resistance goes down, so the current must go up. And and if the resistance stays the same, then the IR, or the voltage, goes up. Another way to think about it is that this was sharing some of the voltage with this resistor before, but now this entire parallel part has the full 10 volts across it. So there's a second way of seeing how the voltage in this branch goes up when that switch is closed. Lastly, let's take a look at 16 and 17. I want to know what is the I in the 3 ohm resistor. All right, got a little ahead of myself and didn't put in enough information. So we have 12 volts, 1, 3, and 6 ohm resistors. We want to know what is the current going through this 3 ohm resistor. All right, so we could get the effective resistance here, add that to this resistor that's in series with it, and get a total current. And then since this resistor is 1/3 of the total here, it's going to get 2/3 of the total current going through it. That explanation has come across in other problems prior to this one. Okay, so here we have an effective resistance of 2, and 2 added to the 1, we have an effective resistance of 3. And so my total current is going to be, my total current is 4 amps, right? And so some of that goes down this way and some of that goes down this way. This is going to get 2/3 of that current, and 2/3 of 4 is 8/3 amps. Lastly, for number 17, I want to know what is the I want to know what the total current is. All right, so here we have a 4-to-1 ratio, and this has 4 amps, right? So if this is a 1 ohm to 4 ohm ratio, then the current is going to be opposite that of 4 amps to 1 amp. And so when they meet up here, it should be 4 plus 1, which equals 5 amps. That's my answer.